where n is a non-negative integer, a1, a2, a0, a all belongs to the real numbers, is called a polynomial function. So f of x is equal to mod x is called the modulus function. For each x belongs to the real numbers is called the modulus function. A function f from R to R is defined by y is equal to f of x, where x belongs to R is called an identity function. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important concept, that is a function, different types of functions and their graph of different types of functions. So you may expect 5 marks question from these graphs. Okay, now let us come to some functions and their graphs. So some important functions. Now the first important function is an identity function. Identity function. Now how to define? In the examination they may ask, define an identity function and write the graph of identity function, and also write the domain and range of the identity function. So identity function, let R be the set of real numbers. Define the real valued function f from R to R by y is equal to f of x. That is, the real valued function f from R to R is defined by y is equal to f of x. Y is equal to f of x. Y is equal to f of x for all x belongs to R is called a identity function. A function f from R to R is defined by y is equal to f of x, where x belongs to R is called an identity function. So here the domain and range of f are R. The domain of an identity function is R, and similarly the range of an identity function is R. The graph is like this. Now if you take x is equal to, if x is equal to 0, then y is equal to function of x, function of 0 is equal to 0. Suppose if you take x is equal to 1, f of 1 is equal to 1. Suppose if you take x is equal to 2, 4, 6, so then you will get y is equal to function of 2 is 2, function of 4 is 4, function of... Similarly, if you take the value as negative, when x is equal to minus 1 and x is equal to minus 2, x is equal to minus 4, the function of minus 2 is also equal to minus 2. The function of minus 4 is also equal to minus 4. Now, to draw the graph for this function, when x is equal to 0, y is also equal to 0. When x is equal to 2, f of x, f of 2 is equal to 2. When x is equal to 4, f of 4 is equal to 4. X is equal to 6, f of 6 is equal to 6. Similarly, for the negative values, when x is equal to minus 2, f of 2 is minus 2. When x is equal to minus 2, f of 2 is minus 4. When x is equal to minus 6, f of minus 6 is. So similarly for, so a straight line which passes through the origin. The graph of this function is found to be a straight line which passes through the origin. A straight line passing through the origin will give a graph for an identity function. So a function y is equal to f of x is called an identity function where x belongs to R. That means here the domain of f is R and the range of f is also equal to R. The graph of this function is, when x is equal to 2, f of x is 2. When x is equal to 4, f of x is 4. X is equal to 6, f of x is 6. Similarly for negative values, we are going to get minus 2, minus 4 and minus 6. So a straight line which passes through the origin will give the graph of an identity function. Okay. Now here the domain of f is R and the range is also. So this is an identity function. Next, this is a 5 marker question. Right. Now let us come to the next one. Now constant function. A constant function, y is equal to f of x is equal to k or c is called a constant function. So how to define a function? Define a function f from R to R by y is equal to f of x is equal to c, where x belongs to R is called a constant function. So y is equal to f of x is equal to c for all x belongs to real numbers is called a constant function. So in a constant function, the domain of f is R and the range is C itself. C is the range. So the graph of the function is a line which is parallel to x-axis. For a constant function, the graph is found to be a line which is parallel to x-axis. Now let us consider, for example, f of x is equal to 3. Here C is equal to 3. For each x belongs to R, then its graph will be a line shown in this figure. So when x is equal to 3, this is 2, x is equal to 3, a graph which is parallel to the x-axis is called a constant function. So the domain of f is R and the range is equal to C itself. So how to define a function y is equal to f of x is equal to C is called a constant function where x belongs to R set of real numbers. So the graph of a constant function is nothing but a line which is parallel to the x-axis. So the range of a constant function is C and the domain of the constant function f is R. Now let us consider, for example, if f of x is equal to 3, y is equal to f of x is equal to 3, then the graph of this function is, it will be parallel, passes through this point and parallel to the x-axis, okay. Now let us come to the next one, third one, polynomial function. Polynomial means a function f from R to R is said to be a polynomial function if for each x belongs to R. That is, a function y is equal to f of x can be written as a0 plus a1x plus a2x square plus a3x cube etc. an x raised to n. Any function, a function f of x is equal to a0 plus a1 into x plus a2 into x square plus a3 into x cube plus etc. an x to the power of n, where n is a non-negative integer, a1, a2, a0, a are all belongs to the real numbers, is called a polynomial function. Let us consider, for example, a function f of x is equal to x square plus x plus 3. This is a polynomial function of degree 2. Therefore, this is called a quadratic equation. Another equation, f of x is equal to x cube plus 4x square plus 3x minus 2. This is also a polynomial equation of degree 3. Suppose if I write x raised to 5 plus 3x cube, 3x square plus 4x minus 1. This is also a polynomial equation of degree 5. So these are all examples for polynomial functions of degree 2, 3 and 5. So a function f from R to R is said to be a polynomial function if f of x is equal to y is equal to a0 plus a1x plus a2x square plus a3 an etc. an x raised to n is called a polynomial function. So a0 plus a1x plus a2x square a3x cube etc. an x to the power of n is called a polynomial function. These are few examples for a quadratic equation, cubic equation, biquadratic equation, equation of degree 5, 6, 7, nth degree all comes under this polynomial equation of degree n. Okay. Let us take a problem. Define the function f from R to R by y is equal to f of x is equal to x square, where x belongs to R. Complete the table given below by using the definition. What is the domain and range of this function? Now, what is to do here means just substitute the values of 0, 1, 2, 3, minus 1, minus 2, minus 3, minus 4 in the given equation. What is given here? Y is equal to x square. This is nothing but f of x. Now, when x is equal to, write down the value, when x is equal to minus 4, from here I will start. When x is equal to minus 4, f of minus 4 is nothing but minus 4 square, minus into minus plus 16. When x is equal to minus 3, f of minus 3 is nothing but minus 3 square, 3 3s are 9 we will get. Similarly, f of minus 2 whole square is plus 4. F of minus 1 whole square is plus 1. F of minus 1 is minus 1 whole square, that's equal to plus 1. F of 0 is 0. Again, f of plus 1 square is 1. F of plus 2 whole square is nothing but 2 square is positive itself 4. 3 square is 9. 4 square is 16. This is the table. So, 0, 1, 4, 9, 16, 1, 4, 9, 16, all positive values they will get. Now, y is, you might have been studied in your previous classes, y is equal to x square is nothing but an equation of a parabola. So, from this previous table, whatever the values we got, I will substitute here. So, these are the values. When x is equal to 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, we are going to get these values. Now, let us draw the graph for this function. When x is equal to 0, f of x is 0. When x is equal to 1, f of x is 1 here. And when x is equal to 2, f of x is equal to 4. When x is equal to 2, f of x is equal to 4. This is 2, 4. When x is equal to 3, f of x is equal to 9 we will get. Here we are going to get. Similarly, when x is equal to 3, we will get f of x is equal to 9 here. Now, similarly for negative values, when x is equal to minus 1, f of x is equal to plus 1 we are going to get here. Now, similarly, when x is equal to minus 2, f of x is equal to plus 4, here it is. When x is equal to minus 4, what is the value we are going to get? 16 here. When x is equal to minus 3, f of x is equal to, for minus 3 we are going to get 9, somewhere here it is. So, plus 9 and minus 9. So, it is nothing but a graph which passes through a line like this. So, a parabola opening upwards. So, here I will write like this here. This is x-axis and y-axis. So, here 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. This is y dash and this is x dash. This is 1, 2, 3, again 1, 2, 3, minus 1, minus 2, minus 3. Then if I draw the graph, see here from this, when x is 0, y is also 0. When x is equal to 1, y is equal to plus 1. When x is equal to 2, y is equal to 4 here. When x is equal to 3, y is equal to how much we are going to get? 3, 4, 5, 6, 7, 8, 9. Okay. Similarly, when x is equal to minus 1, the value of y is plus 1. When x is equal to minus 2, the value of this is plus 4. Similarly, when x is equal to 3, y is equal to, when x is equal to minus 3, this is plus 9. So, this is nothing but a curve which passes like this. So, this is y is equal to x square, same thing. That means the equation of a parabola which opens upwards, y is equal to x square, that is it. Okay. Here, what is to find the domain and the range? The domain is nothing but, the domain for this function is the set of all real numbers. The domain is a set of all real numbers, and the range is nothing but all the values which are greater than or equal to 0. That's it. The range is the set of all values greater than or equal to 0. Okay. That is the range and domain. Let us come to the next problem. What is the problem? Draw the graph of the function f from R to R defined by f of x is equal to x cube. Okay. What is given? F from R to R is defined by f of x is equal to x cube. Let us take f of 0. F of 0, that is 0 cube is equal to 0. F of minus 2. Minus 2 is nothing, minus 2 whole cube is minus 8. F of minus 3 whole cube is minus 27. Similarly, f of plus 2 is nothing but 2 cube is equal to 8. F of plus 3, that is equal to 3 cube. 3 cube is equal to 27. These are the values. Now substitute this in a graph. Draw a graph for this. When x is equal to 0, what we will get? Y is equal to x cube here. F of x is equal to x cube. So this is 0 cube is 0. So when x is equal to minus 2, let us take x is equal to minus 2, then minus 2 whole cube is equal to minus into minus 8. Now suppose when x is equal to plus 2, what we will get? F of plus 2 is equal to 2 cube is equal to 8. Similarly, when x is equal to minus 3 and x is equal to plus 3, what is f of minus 3? Minus 3 whole cube is minus 27. F of plus 3 is equal to plus 3 whole cube is equal to plus 27. So here, see here, just when x is equal to 0, y is also equal to 0. Let us consider the positive value. When x is equal to plus 2, y is equal to, what is the answer we are going to get? Plus 8. So this is 2 comma 8. Similarly, if x is equal to 3, x is equal to plus 3, y is equal to plus 27. Somewhere around this point we are going to get. Now similarly, for negative values, when x is equal to minus 2, what is the f of x? We are going to get it as minus 8. So when x is minus, this f of x is also minus. Similarly, when x is equal to minus 3, f of x is minus 27. So first you are going to get. So a graph is found to be a line which passes through the origin. So this is the graph for the function y is equal to x cube. So when x is equal to positive value, we are going to get positive. When x is equal to negative, f of x is negative. So a line which passes through the origin like this is the graph for the function y is equal to x cube. Okay, now let us come to the next problem. Define the real valued function f from r minus 0 other than 0 to r defined by f of x is equal to 1 by x, where x belongs to r minus 0 other than 0, all real numbers except 0. Complete the table given below using the definition. What is the domain and range of this function? What is given? F of x is equal to 1 over x. 1 over x. Now, what is to find? Just find out these values. When x is equal to minus 2, for x is equal to minus 2, then f of minus 2 is nothing but 1 by minus 2. This is 1 divided by minus 2. Similarly, when x is equal to minus 1.5, f of minus 1.5 is 1 divided by minus 1.5. Minus 1 divided by 1.5. So similarly, this is when minus 1 by 1 is minus 1. This is minus 1 by 0.5 plus 1 divided by 0.25. This is 1 divided by 0.5. 1 by 1 is 1, 1 by 1.5 and 1 divided by 2. 1 divided by 2. So I can write this here. These are the values. So minus 2 divided by minus 1 by 2 is nothing but 0.5. So 0.5. 1 divided by minus 1.5 is minus 0.6. 1 divided by minus 1 is minus 1. 1 divided by minus 0.5 is minus 2. And 1 divided by 0.25 is 4. And 1 divided by 0.5 is plus 2. 1 divided by 1 is 1. And similarly, 1 divided by 0.5 is 0.67. 1 divided by 2 is equal to 0.5. So these are the values. Now here, if I draw the graph for this, when x is equal to minus 1, f of x is equal to minus 1. So when x is equal to minus 1, f of x is minus 1. Similarly, when x is equal to minus 2, f of x is also minus 2. And when x is equal to minus 2, f of x is minus 0.5. And similarly, when x is equal to plus 2, y is equal to plus 0.5. Similarly, when x is equal to 0.5, y is equal to 2, we are going to get 2. Here 0.5, we are going to get 2. And similarly, when x is equal to minus 0.5, when x is equal to minus 0.5, minus 0.5 means here we are going to get minus 0.5. Then the value of y is equal to minus 2. So here we are going to get for minus 2. And similarly, when x is equal to plus 1.5, when x is equal to 1.5 here, then what is the value we are going to get for y as 0.67. Somewhere here we are going to. So therefore, if we draw the graph of the function is found to be like this for y is equal to 1 over x. This is the graph for the function y is equal to 1 by x, f of x is equal to 1 by x. Now, the domain is a set of all real numbers. The domain for this is the set of all real numbers except 0, and its range is all the real numbers except 0. So, the domain is nothing but the set of all real numbers except 0, and its range is all the real values, all the real numbers except 0. The graph of the function is shown like this in the figure. So this is the graph for the function y is equal to 1 over x. The value as x increases, y goes on decreases. So as x increases, the y value goes on decreases. So that is an exponential function. So as x increases here, as x increases from 0.5, 0.25, 0.5, 1, 1.52, the value of this goes on decreases 4, 2, 1, 0.67, and so as this x increases, the value of y goes on decreases. Here also the same concept. So therefore this is y is equal to f of x is equal to 1 over x, the graph for the function, and the domain is a set of all real numbers except 0, and its range is also all real numbers except 0. Okay. Now let us come to the next type. This is very important type of function. You may expect this for 5 marks in the examination. In the examination, they must define the modulus function, write its graph, and write the domain and range of a modulus function. Now, how to define the function f from R to R is defined by f of x is equal to mod x. So, f of x is equal to mod x is called the modulus function. For each x belongs to the real numbers is called the modulus function. For each non-negative value of x, f of x is equal to x, and but for negative values of x, the value of f of x is negative value of x. So that means when x is greater than or equal to 0, f of x is equal to plus x. When x is less than 0, f of x is equal to minus x. That means for each non-negative value, f of x is equal to plus x. For negative, f of x is equal to minus x. That is nothing but f of x is equal to x if x is greater than or equal to 0, minus x if x is less than 0. If x is positive, this is positive. If x is less than 0, then it is equal to minus x. So therefore, the domain of the modulus function is R, and the range is the set of all non-negative real numbers. Range is nothing but the set of all non-negative real numbers, whereas the domain of the function is R. Now the graph for the function is found to be like this. When x is equal to plus 2, y is equal to plus 2. When x is equal to plus 4, y is equal to plus 4. When x is equal to 6, y is equal to plus 6. Similarly, when x is equal to minus 2, this is, you are going to get it as a positive value. This is, and x is minus, then plus 4. When x is equal to minus 6, this is plus 6. And when x is equal to minus 8, plus 8. So therefore, this is the graph, a line which passes through like this. This is the graph for a modulus function. So V-shaped curve. So here the graph of the function, modulus function, is found to be like this. So for each x is equal to 2, we will get y is equal to 2, x is equal to 4, y is equal to 4. Similarly, when x is equal to 2, minus 2, f of x is equal to plus 2. When x is equal to minus 4, f of x is also equal to plus 4. So therefore, when x is greater than or equal to 0, f of x is equal to plus. When x is less than 0, f of x is equal to minus x. So this is the graph of a modulus function. Followed? This is very important and simple concept. So I will repeat once again. A function f from R to R is defined by f of x is equal to mod x. For each x belongs to R is called the modulus function. For each non-negative value of x, f of x is equal to x. But for negative value of x, the value of f of x is negative of the value of x. That is, if x is greater than or equal to 0, f of x is equal to x. If x is less than 0, f of x is equal to minus x. And therefore, the domain of the function f is R, and the range of the function f is the set of all non-negative real numbers. And this is the graph of the function y is equal to f of x, that is nothing but mod x. Okay. The next one is the Signum function. Signum function. So how to define the Signum function? This is also very important for the point of examination. You may get this for 5 marks. Now in the examination, they must define a Signum function, write its graph, and also write the domain and the range. Now let us define the Signum function. A function f from R to R is defined by f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, and minus 1 if x is less than 0. So for all positive numbers, positive values, it is 1. When x is equal to 0, it is 0. For negative values, that is equal to minus 1, is called the Signum function. And for a Signum function, the domain of f, the domain of the Signum function is R, set of all real numbers, and the range is a set which contains minus 1, 0 and 1. So, the domain of f is R and the range of the f is minus 1, 0 and 1. So, usually this is denoted as f of x is equal to mod x divided by x. See, when x is greater than 0, what we will get? F of x is equal to, when x is greater than 0, for positive value the modulus of x is x divided by x is equal to 1. When x is equal to 0, f of x is equal to, when x is 0, then modulus of 0 is 0 divided by x is x itself, positive number, then we are going to get it as 0. Similarly, when x is less than 0, f of x is equal to, modulus of x is, when x is less than 0, this is minus x divided by x, this is equal to minus 1. So, therefore, the values of f of x are 1, 0, minus 1. If x is greater than 0, it is 1. If x is equal to 0, this is 0. If x is less than 0, this is equal to minus 1. So, therefore, such a function is called as the Signum function. Okay. Now, the graph of this Signum function is when x is equal to 0, when x is equal to 1, y is equal to 1, when x is equal to minus 1, y is also equal to minus 1. This is the graph of the Signum function. Okay. Now, let us come to the next one. The function f from R to R is defined by f of x is equal to x is called the greatest integer function. Now, greatest integer function, a function f from R to R is defined by f of x is equal to like this, x. So, is called, where x belongs to R is called the greatest integer function. So, here f of x is equal to x means x belongs to R. Assume that the value of the greatest integer is less than or equal to x. Such a function is called the greatest integer function. The value of x which is less than or equal to x is called the greatest integer function. For example, the greatest integer value of x is equal to minus 1, where x lies between minus 1 and 0. Minus 1 less than or equal to x, less than or equal to 0. Similarly, the greatest integer value of x is equal to 0 is 0 less than or equal to x, less than 1. Similarly, for x is equal to 1, 1 less than or equal to x, less than or equal to 2. The greatest integer value of x is equal to 2 is 2 less than or equal to x less than. That means, the value of the greatest integer function is less than or equal to, less than. So, x is 2 less than or equal to x less than 3 is called the greatest integer function. The value of x such that which is less than or equal to x of a function is called the greatest. The value of x which is less than or equal to x is called the greatest integer function. So, these are few examples for a greatest integer function. Now, how to draw the graph of this greatest integer function? So, if f of x is equal to x is called the greatest integer function. So, here the graph of this is found to be like this, 1 to 2. So, the value of x which lies less than or equal to 1 to 2, 2 to 3 and 3 to 4. Similarly, minus 1, minus 2 and minus 3. So, 1, 2, 2, 3, 3, 4. And again, this is 0 to minus 1, minus 1 to minus 2 and minus 2 to minus 3. This will give the graph of the greatest integer function. So, like this is the greatest integer function, and the domain of the greatest integer function is all the set of real numbers, whereas the range of f is the z. Z itself is the range and the domain is the set of all real numbers will comes under the greatest integer function. Okay, you followed this. So, the greatest integer function means the value of x which is less than or equal to x is nothing but the greatest integer function, and the graph of the greatest integer function is, this is the graph for the greatest integer function. So, 1 to 2, 2 to 3, 3 to 4. Similarly, 0 to minus 1, again minus 1, minus 2 and for a minus 3. Okay. Now, that is regarding the different types of a function. So, these are few examples for different types of function and the graph and the range and the domain. So, that is all for today's session. Let us meet with a different concept in the next class. Thank you very much.